Sustainability is one of the biggest discussions in the world, and the Energy Safety Research Institute at Swansea University is leading the RICE initiative that is using new and demonstrable technologies that allow for CO2 to be used in an environmentally friendly way, from plant feed to pharmaceuticals. We went to investigate.
At this nickel refinery in South Wales, what used to be a problem waste product is now considered a valuable commodity.
We're taking this CO2 effluent and we're using it to grow algae. Algae themselves photosynthesize, and in that process they suck up the CO2, and we then take that algae and refine those into natural products that we can then use for commercial purposes.
The Reducing Industrial Carbon Emissions Project, or RICE for short, was set up to improve the use of carbon within the circular economy. It's backed by Welsh Government and EU funding.
For every kilogram of algae that we produce, we capture roughly 2 kilograms of CO2. So as you can see, this is a great way to mitigate climate change, but also capture and reuse that carbon. And one of the things we want to do is integrate this process further to work with local agriculture and take nitrates and phosphates from animal waste and anaerobic digestion wastes and integrate those into this process as well. And therefore we'll generate a true circular economy that generates value in terms of the product portfolio that we can achieve from the algae themselves.
At the Energy Safety Research Institute's on-site lab, researchers are measuring the yield from different species of algae. The purpose of this facility is to road test the technology in a real-world environment, both to check that it's commercially scalable and to de-risk the investment.
It's critically important that we get this real-world analysis and data. Without this, we would be unable to go through our capital process and invest. It needs to have a certain readiness level to allow us to invest as a company. So it is crucial that this work is progressed with industry so that we can have that real-world results. Working in the collaboration with the university gives a real good platform to give us real-world results that we can then use to justify capital expenditure and investment.
For Esri's director, there's recognition that just because a new technology works well in the lab, getting industry buy-in requires data about performance in practice.
We try and de-risk the technology in multiple different ways so that if an industry is looking to adopt it, they can say, does this meet our safety requirements? Oh yes, it's been on a Coma 1 site. We know that it's operated for 18 months without incident and it's been successfully demonstrated. That's fine. Is it going to be economically viable? Well, during that period, there's been an economic assessment of the technology. And yes, we know we can have a return on investment of, let's say, 3 years. And so now you've de-risked the technology, the implementation of the technology for industry. And that's really what they need. Otherwise, they're just going to stick with whatever's commercially out there that's presently available. In order to overcome these emission targets or get to the emission targets of net zero, we're going to need to do every single little piece of technology. So for any specific industry, they're not just going to adopt one technology and solve all their problems. What they're going to do is adopt one technology that will solve some of their problems. They'll adopt a different technology which will interface with the first. So it's not only that there's not one solution, but we also need to create a symbiotic relationship between the different solutions and industries adopting those different solutions.
So this is your trial unit. As well as using algae for carbon capture, Valley Europe is also trialling a range of solutions to different problems. Using water and renewable energy to produce hydrogen instead of natural gas is one of the ways it's reducing carbon emissions.
Well, this is an electrolyser to produce hydrogen gas. The voltage that's passed across the cells splits the water into its component gases, and then they can use that in their process just as they would their other hydrogen.
But in a much more environmentally friendly and sustainable way.
That's right, yeah.
And by developing a range of technological solutions to produce and absorb different gases, not just good for the planet, but good for business as well.